topics that have been covered in the week one tasks. So week one was covering mainly chapter 18. So I want to first start with any questions that you've had while watching those video recordings and completing the week one tasks. So please let me know in the chatting box if you've got any questions. And if you didn't, please let me know also that you're doing okay. Doing good, good. No questions.
Sir, I have a question. Understanding the video, I'm good, but I don't know. This week, that after test, or you said that we have to make a Word documents, or in that we have to submit the homework and question and answer. So that how we can do that, and how to submit that one.
All right, so for the in-class activities, those are going to be addressed during our live meetings. So after I take your questions, I answer any, if you've got any questions, uh, I will be addressing some questions related to the tasks that have been covered in the previous week, and you're gonna be answering them in a Word document that you're gonna be submitting at the end of the semester. So those questions are the ones that will be addressed during our live session, like today. So we're gonna start with those questions in a minute after I just complete your questions if you've got any. All
Okay, so
right.
we have to make our own Word documents, and we have to make a file and save it till the end of the semester, and then we have to submit.
Yes, exactly.
Okay, thank you.
For the visible body courseware, you can't save your work in the middle, so you need to get it completed, and once you've completed it, you can come back and redo it one more time. But you can't leave the assignment in the middle and come back to it to get it completed. So you need to get it completed in one setting. This is what Hannah is asking. So if you started a quiz, for example, that is an assignment on visible body, you need to get this specific one completed in order for it to be considered, and then come back to it later on. But every time you're gonna to start the quiz, it's gonna start from the beginning as if it is your first time to get to work on it. But you have unlimited attempts to get it completed.
And sir, I had a problem, and I emailed for that also about proctor test, that
Mhm.
syllabus test. But for the retake test, I didn't get any means access. They didn't allow me access for without having access code. So how
Did
to
you try to contact the support? Did you chat with the support with a live person?
No, I didn't do that.
So, in order, because I even me, I can't modify if there was a system glitch. I can't overcome it. I can't resolve it. So you need to go to the support down in the uh, right corner of the page. There is a tab that says support. You start to chat with a person, and they should be able to resolve the issue for you. That's why I recommend you to start any proctored exam at least 24 hours before the due date for you to get enough time if you've got any system problem to resolve it before the due date. All right, so and the support, if when you contact the support and they need me to do something for you, they are the ones who will contact me in most cases for me to modify something on my end.
Okay, and one more question, if we go to Proctor and want to take a retest, we have to take right away, or we can take the next day also, or we have to finish the right away. How many attempts we have to attempt? Two attempts
So
allowed.
you won't face this any other time because the only one that has retakes
Okay.
is the syllabus quiz. All the other proctored exams, they have only one attempt.
Okay.
All right, so you won't face this problem uh, any other time because you, so the it, so what I figured out is that they first allow you to complete a retake through smarter proctoring on the same setting. So once you open it, you need to complete all of the 3 attempts. You can't leave and then come back to get it completed. And this is what creates the confusion. But I contacted them and allowed them to reopen it 3 more times. But because they did it manually, it seems that some of you did experience some glitches in the system. I will put this into consideration. I will put this into consideration. I will give you another assignment with extra credit to substitute if you did have problems with the subs.
Yes, sir. Please. Thank you so much.
You're welcome. Yeah, so Visible Body now, they are doing a maintenance through their website, so you should be fine in a day, I believe. Kimberly is asking if Terrell and Kimberly are asking if there is a problem with Visible Body. Yes, they are doing a maintenance on their website, so it should be good within a day. All right, any other questions related to the material or related to the course structure or assignments or activities? All right, so let's start here. So now we're starting the virtual class activity questions. So those are the ones that you're gonna need to complete in your Word document that you're gonna be keeping until the end of the semester to submit it. All right. All right, for the first set of questions, please identify the numbers. I will be giving you a few minutes to think about them, and then we're going to discuss them together. So please identify the different parts of the heart and the associated blood vessels on here. So what you're going to need to do is just to list your answers in the Word document. Yes, they will be slightly different from the ones in your videos. Yes, they will be slightly different. So what I'm expecting you to complete are the ones I'm addressing during the live sessions. All right, they will be slightly different compared to what you do have already in the video recordings. All right, so please complete the markings on this diagram. So what you are going to be listing, you're going to be writing down the answers in a formal list, the number, and your identification next to it. I'll give you 2 minutes. Yesenia, I can't understand what do you mean by not the video. No, you don't need to write down the ones from the video, no. Only the ones that I'm addressing during the live sessions. Only the ones that I'm addressing during the live sessions. All right, so can you tell me here what you've got for number one? What's number one? This vessel, it carries the blood from the different body organs located above the diaphragm, and it's carrying deoxygenated blood towards the heart. If I'm carrying blood towards the heart, it's a vein, if you remember. It doesn't matter whether it's carrying oxygenated or deoxygenated blood. What matters for me is the direction of the blood flow. So this is one of the largest veins that we've got in here. This is my, exactly as you mentioned, superior vena cava. Another vein, number two, what you've got for number two here. This is another vein that will be draining the deoxygenated blood from the body organs located below the diaphragm. So we call this one, it's my inferior vena cava. if you remember, a small chamber of the heart that receives blood is going to be an atrium. Small chamber that receives blood, it's going to be an atrium. So you've got two atria on here. This one is going to be on the right side. Remember, as if you're looking at the chest of a person in front of you, you're facing him. So this side is going to be his right side. So this is going to be my right atrium. This is the one that receives the deoxygenated blood from the different body organs. It's associated with how many vessels? Do you remember? How many veins are draining deoxygenated blood into my right atrium? So we've seen here two of them, superior vena cava, inferior vena cava. Is there any other one? Is there any other one that is not shown on here on this diagram? Yeah, what do we call the third one that's going to be draining the heart itself? It's my coronary sinus. Coronary sinus. So this is our third vein that drains deoxygenated blood again. Coronary sinus is draining the cardiac muscles. All right, so we've got three major veins draining the deoxygenated blood from everywhere in your body to the right atrium. Superior vena cava drains everything above the diaphragm. Inferior vena cava drains everything below the diaphragm. The coronary sinus is the third vein that drains the deoxygenated blood that has been consumed uh, by the heart itself. If you remember, the circulation, the cardiac circulation, is a unidirectional flow. What I mean by unidirectional flow, so the blood moves forwards and keeps moving forwards. It doesn't go back. It doesn't move backwards like this. It doesn't go backwards like this. It only moves forwards. It's a unidirectional flow. What allowed me to keep my blood moving forwards is the presence of valves. And we've got two different types of valves. We do have valves located between the atria and the ventricles. Atria and ventricle. You have a valve on here, you have a valve on here. So the valves that are located between the atria and the ventricles, those are what we've called the AV valves or the atrioventricular valves. AV valves, atrioventricular valves. Those are the ones that are located between the atria and the ventricles. So on the right side, what do we call the AV valve on the right side? This is the one with three leaflets. I have three cusps. Those cusps are directed downwards like this. So they will allow the blood to move down. But once the blood is trying to move up, they close. So we call this a specific valve on the right side between the right atrium and right ventricle. This is my tricuspid valve. Tricuspid valve. And the blood, after it leaves the right atrium down through the tricuspid valve, it's going to reach a large chamber of the heart with a thick wall compared to the atrium that will allow me to pump the blood for a long distance. So the atria can't pump the blood for long distances because simply they have a very thin wall of the chamber. So the chamber that allows you to push the blood for a long distance is gonna be a ventricle. This is what we call the large chamber of the heart. And this specific ventricle, it's located on the right side. So we're gonna call it my right ventricle. What happens next? The blood gonna be leaving the right ventricle, passing through another valve located at the base of this large vessel. It allows the blood to move up, but when the blood tries to move back down, it closes. So it allows only the blood to move forwards, like this. So what do we call this valve? It looks like half moon, so we call it semilunar. It's a semilunar valve. And this specific semilunar valve, it's located at the base of this large artery that will carry the blood towards my lungs. So I'm going towards the lungs. So something related to the lungs is going to be pulmonary. Pulmonary. So we're going to call the valve at the base of the vessel on here. It's my pulmonary semilunar valve. And this thick and short vessel that will carry the blood up towards my lungs, thick and short vessel on here, it's gonna be my pulmonary trunk. The pulmonary trunk, it's an artery, but we don't call it artery because simply it's short and thick. So a vessel that is short and thick, we call it a trunk. But actually it's carrying the blood away from the heart, so it's actually an artery. The two branches on here of the pulmonary trunk that will be delivering the blood towards our lungs. So you've got a right vessel and a left branch, right branch, left branch, to deliver the blood to your lungs, right and left. Those are my, as you mentioned, great, thank you so much. Those are my right and left pulmonary arteries. Right and left pulmonary arteries here is number 8. So what happens in the lungs? As anything in nature will be moving from high pressure to low pressure. This is a deoxygenated blood. What I mean by deoxygenated blood, it has a low concentration of oxygen. So here, let's see what happens in the lungs. The blood has low oxygen partial pressure. So I have low tension, low pressure of oxygen. So when the blood gets in contact with my air sacs, like this, in which I have high pressure of oxygen, what's going to happen? The side with higher oxygen levels will allow the oxygen to move from its high pressure within the air sacs to its low pressure within the blood. And now the blood gonna be oxygenated. What I mean by oxygenated, it has high pressure of oxygen. So the blood goes into the lungs with low oxygen pressure. It leaves the lungs to return back to the heart with higher oxygen pressure, and we call this is an oxygenated blood. So now the oxygenated blood is going back towards my heart. So what do we call the vessels that will be returning the blood to the heart? Do we call them arteries or veins? What do you think? Veins. So number 9 on here is marking what vessels? Number 9 here is marking what vessels? The veins draining the lungs. So if I am related to the lungs, I am called pulmonary. So we're going to call those are my pulmonary veins. And how many pulmonary veins do we have? We have 4 of them. We have 2 coming from each lung. So we've got 2 left pulmonary veins, 2 right pulmonary veins. All right. So on the diagram that you've seen in the PowerPoint presentation, you see only from one side. You don't see the 4, you only see 2 of them. The same way I did draw this diagram. All right. But for us, you don't have to mention those are left or right pulmonary veins. What you should just mention is that those are my pulmonary veins. And the pulmonary veins, if you see on here, are gonna be getting the blood towards a small chamber. If you remember, what chamber, what do we call the small chambers of the heart that look like ears? Yeah, atrium. And this atrium is on the left side, so we're gonna call it my left atrium. The left atrium will be allowing the blood to move down towards my large chamber on here, passing through another AV valve. What do we call this AV valve? What do we call this AV valve? On the left side, between the left atrium and the left ventricle, it's my mitral valve or bicuspid valve. If you remember, why do we call it bicuspid? Because it has 2 leaflets. Unlike the tricuspid, it has 3 leaflets. It has 3 leaflets. This one has only 2. And we call it mitral because mitral is the bishop. So if you remember from the recorded session, it looks like the bishop hat. That's why we call it mitral valve. Mitral means related to the bishop. All right, so number 12 here is this large chamber. Yeah, my large chamber on here, it's gonna be my left ventricle. Left ventricle. Then left ventricle, if you remember, is gonna be pushing the oxygenated blood to be delivered to every single body organ. All the body organs are going to be receiving their oxygenated blood from the left ventricle through what vessel on here that will be distributing all the oxygenated blood? What is number 14 first? Oxygenated blood going to be delivered to all body organs. All body organs, it's going to be my aorta. And what allows me to push the blood into the aorta without allowing it to go back is a semilunar valve at the base of the aorta. So what do we call the semilunar valve located at the base of the aorta? It's my aortic semilunar valve. Aortic semilunar valve. So again, a quick review of what we've mentioned so far. So again, those are your virtual class activity questions that you are supposed to submit at the end of the semester. You are expected to complete only the ones that we address live in our weekly meetings. Those are the first questions for this semester and for this session. All right. So what you're gonna need to type is week 2 meeting or week 1 activities, and then you start to list the answers for the questions. So today we have got so far 14 questions. So what you're gonna be writing down. If for any reason you didn't get a chance to type while you are attending the session, you simply can take a screenshot of what you have on your screen and take your time after this session to type down your answers if you didn't get a chance to type it as we go. All right. So again, two veins on here are draining the deoxygenated blood. Superior vena cava, inferior vena cava. They drain the deoxygenated blood from the different body organs into a small chamber on here. This is my right atrium. Right atrium will allow the blood to travel down, passing through the tricuspid valve to reach the right ventricle. Right ventricle gonna be to be pumping this deoxygenated blood through the pulmonary semilunar valve, allowing the blood to travel into the pulmonary trunk. Then it gets delivered to the lungs through the right and left pulmonary arches. The lungs will be responsible to perform the gas exchange. Now the blood drained from the lungs is going to carry high levels of oxygen. We call this blood it's oxygenated blood. It returns back to the heart, and remember the vessels that will be returning the blood to the heart, those are what we call the veins. And you see here, these veins are going to be getting the blood to the heart from the lungs. So they are related to the lungs. So we call them the pulmonary veins. They will deliver the blood to my left atrium, and left atrium will allow the blood to travel through the mitral valve to the left ventricle. Then from the left ventricle, the blood gets pumped into the pulmonary, into the aorta, and this will be allowed to take place by allowing the blood to pass through the aortic semilunar valve. This is where the blood gets distributed to all the different body organs. I see here that some of you have been asking questions, so let me all right, so Diona, which labels do you want me to repeat again? Which label? Yeah, is this week 1? So you can either, both are acceptable. Either you call it week 1 tasks, or you call it week 2 meeting. They are the same for us. So if you decided to go by meeting, so you're gonna start with week 2. So you call it week 2 meeting. If you decide to go with the tasks for your reference to match the discussion boards, so you label them each week, week 1, week 2, according to the tasks that we are going to be completing. All right, so you either state it's week 1 tasks or week 2 meeting. Does this make sense? All right. So to be clear, we're doing all this in a Word document and label it week one. Yes, so you either label it week one tasks or week two meeting. All right, but we're gonna keep going. You're gonna be listing all the answers. Some of the questions I will be addressing, you're gonna be completing on your own as part of the virtual class activity questions, as you're gonna see in a second. This one document is labeled with each week submitted at the end of the semester. Exactly, Jezebel. Thank you for answering. So are there actual questions that I missed, or do we write? Yeah, so you didn't miss any questions. You see here, those are the 14 questions that we've completed so far. Do we need to include the date of the meeting? You don't need to, but you can write it down. No problem with it. If you will find it easier for you to keep track of the meetings, to write down the dates, I highly recommend it. But if you don't, that's okay. So today is week one task, week two meeting, and we write down the answers from today's questions, right? Yes, exactly. So you're gonna be writing down in your Word document or whatever software that you're using, Pages, you are using Adobe Acrobat to create your documents that you're going to be submitting at the end of the semester. So you're going to start first by writing down week one tasks or week two meeting. If you wanted to write down the date for today, that's okay. And then you're going to start listing the answers. Some people do draw the diagram and put the labels on it. Uh, it's not mandatory to do so. But if you want to do it like this, to take a screenshot of the question and then add the answers, this will be great. If you don't want, you can just list the answers. But people do uh, answers the questions in different ways. All of them are acceptable as far as they are complete. And we don't need to do anything with the questions in the videos, just disregard. Yes. So you will see me addressing questions in the videos, in the video lectures. Those ones, please disregard them. I'm not asking you to get them completed. I want you to only answer the ones that we're going to be addressing in the live meetings. All right. Any other questions? Any other questions? All right. So let's check on here. Another very important topic. So I want to check out with you. If you remember, as we have discussed, the heart is different from the skeletal muscles, that it has its own muscle cells that create the electrical impulses that will allow the heart to contract. So I'm not relying on external source for electrical impulses. I have my own electrical impulses created within the heart. So as I mentioned last time, yes, this is recorded and I recorded only for my own records. So if a person misses a class for an emergency, you can contact me to give you a copy of this recording, but it's not made available for the class. All right, because I want you to be attending the live session, not relying uh, on the recorded session. All right, so but all the information, all the required information has already been posted in recorded videos on Canvas. So there is nothing new that we're covering here. All right. So the special parts of the heart that have the ability to create their own electrical impulses, they are characterized by having automaticity. What I mean by automaticity, they create their own electrical impulse without the need of external nerve signals. So if I take out the heart will keep contracting, relying on the electrical impulses created from within. We've got multiple parts of the heart that have the ability to create the electrical impulses. So can you tell me here? Looking here at how the electrical impulses are going to be created and will be traveling towards the different parts of the heart. So we're looking first, what are the three different parts of the heart that have the ability to create their own electrical impulse, their own action potential? So this is going to be number 15. 16 and 17. Can you name those three for me and tell me what is the rate of depolarization for each of them? So please name the three parts that have automaticity that can create their own electrical impulse that the heart will follow to contract. So the first one, number 15, is my SA node, sinoatrial node. And what is the rate of depolarization for the SA node? On average, it's 75 depolarizations per minute. This is my pacemaker. This is the fastest node in the heart. This is the one that everybody gonna be following normally. What if a person got a myocardial infarction that caused the destruction of the cells of the SA node? Will my heart stop beating? Would my heart stop beating? No. I have a backup pacemaker. What is the backup pacemaker that I have? If a person has lost his SA node for any reason, what is the backup pacemaker? The one on here that is located between the atrium and the ventricle on the right side. So we call this one, it's my AV node. Many people, it's a very common mistake. They relate the AV node to the AV valves. So there is nothing to compare the AV nodes to the AV valves. AV valves are connective tissue leaflets that will be allowing the blood to move down and prevent the blood from moving up back to the atrium. This is the AV valves. AV node is cardiac muscle cells, not connective tissue, not fibers. Those are cardiac muscle cells that have the ability to create electrical impulses. So they normally going to be conducting electrical impulses. If they are not the pacemakers, they will follow like the rest of the heart. But if for any reason the SE node is not functioning as it is supposed to, the AV node will take over and will start to create its own electrical impulses at a rate of 50 depolarizations per minute. And each electrical impulse, each action potential that I create, it corresponds to a contraction followed by a relaxation. Each of those 75, if I'm following the SE node, it's a depolarization, then a repolarization. Depolarization, repolarization, depolarization, repolarization. So each of those is going to be corresponding with contraction and relaxation. You depolarize, you contract. You repolarize, you relax. Depolarize, contract. Repolarize, relax. So when I say SE node is allowing 75 beats per minute, this means what? This means that it did create an electrical impulse that is going to be traveling like this in my cardiac muscle cells. It has a depolarization phase followed by a repolarization phase. This is my action potential. Those are the changes in the electrical potential of the cardiac muscle cell membrane. So 75 electrical impulses created, they are corresponding to 75 contractions per minute. And the contraction of the heart is what we call a beat. All right, so don't confuse the SE node with the contractions. All right, so the SE node, by creating electrical impulses, it causes contractions. All right, is this clear for everybody? Is this concept clear? All right. The third possible pacemaker, I will rely on it in what case? If the ventricles are not receiving any signals from both the SE node and the AV node. I'm not receiving any signals from both of them. So I will rely on number 17, which is my Purkinje fibers. And the Purkinje fibers have the slowest rate of depolarization. They are depolarizing at 30 depolarizations per minute, which will barely keep a person alive. So a person can't perform his daily basic activities with that very low heart rate. All right, you won't be able to pump enough blood to the tissues if you are performing only 30 beats per minute relying on the Purkinje fibers. So when we look at the electrical changes of the whole heart by a machine, we call this as an EKG. So following here, the changes that are taken in the cardiac muscle cells, electrical changes, we are recording them. So if you remember, the cardiac muscle cells have a slightly different action potential compared to the skeletal muscles and the nerves. So you see on here, I have, this is the first phase. This is the depolarization. And then it's going to be followed by a repolarization phase. So all this is my repolarization. What makes the action potential of the cardiac muscle cells, the contractile muscle cells, different from the skeletal muscles and the nerve cells is the presence of this phase in which I have extended the time for repolarizing, called the plateau phase. So when I record the normal electrical changes of the heart, what am I going to be seeing on here? So as a node creates its own electrical impulses, so the signal going to be traveling. Remember, the cardiac muscle cells are going to be connected by gap junctions. So the electrical impulse going to be passing freely between the cardiac muscle cells. But why only the atria first? Because I do have less gap junctions in the AV node, and this is the only way to be connected to the ventricles. So the electrical impulse is going to be delivered to all the cardiac muscle cells of the atria, both atria in the same time. Then it's going to be passing through the AV node, then AV bundle, then the right and left bundle branches like this to reach the Purkinje fibers. And when I reach the Purkinje fibers, this electrical impulse is going to be delivered to the cardiac muscle cells of the ventricles, causing the electrical change to take place within my ventricles. So if I am recording all those electrical changes, I will see on the machine those waves recorded. Can you name those waves for me and tell me the significance of each of them? So not one on here. So here were 17. This is going to be 18. What do you think is number 18? What do we call this first wave? Exactly, it's my P wave. And what is the significance of the P wave? What is the P wave is marking? P wave is marking the atrial depolarization, exactly. Atrial depolarization. How about number 19? Why do I have a delay in here? I have nothing changing. I have nothing changing because I have slow conduction of the electrical impulses passing down through the AV node. So what is number 19? What do we call this complex of waves? It's my QRS complex. And the QRS complex is marking what electrical change within my heart. If you remember, you either have a depolarization or a repolarization. Is this a depolarization or a repolarization, and of which part of the heart? The QRS. It's marking the ventricular depolarization. How about number 20? What is number 20? What do we call number 20? It's my T wave. And the T wave is marking what? Yeah, repolarization of what? Of my ventricle. So it's marking the ventricular repolarization. Ventricular repolarization. All right, so those are pretty much the big topics I wanted to review with you today. So you can see on the discussion board the second discussion that has been posted, which is week 2 agenda. Please complete the tasks that have been recommended on week 2 agenda. Again, when I put a quiz to complete on the agenda, this doesn't mean it's due on this week. It's just a recommendation for you to get it done on this week, but it's gonna still be due as has been scheduled. All right, so when I put on the agenda to complete a quiz or an assignment, it's only a recommendation to get it completed. It doesn't make it due on this week. All right. Any questions? Any questions? The circle in blue here, you see, I don't have electrical change. The machine is not recording anything. Machine is not recording anything. And this is due to what? This is due to the slowing of the electrical conduction that is taking place while passing through the AV node. All right, so I'm not depolarizing the atrium, I am not depolarizing the ventricle. The electrical impulse is slowly passing from the atrium to the ventricle. All right, so at this point in time, this 0.2 second, the machine is not recording anything. That's why it's marked as a flat line. Does this answer your question? Who was Chadwick? Lab assignment is covering chapter 18 and 19. So the hard part of the lab assignment is only chapter 18. The vascular part that I didn't recommend to complete yet, it's going to be covering chapter 19 or related topics to those chapters. So the recommended assignments for week 2, those are related to chapter 18 mainly. All right. Next week in recommendations, recommended tasks for week 3, those gonna have the tasks more inclined towards the vascular system, which is chapter 19. But now we're still working on the heart part, the cardiac part of the cardiovascular system, which is, yeah, point one. Yes. So let me Here, let me check the uh, the information that is given to you to not get you confused. All right, I know it's gonna be slightly different from one textbook to the other, so let me double check on here what is exactly is stated on your textbook just to not confuse you. Yes, it's point one. It's point one. The AV node the time delay, it's 0.1 second. This is the one that I will need. So when the question is addressed to you, you are expected to know that this is 0.1 second. All right. Exactly. So that's why if a person if a person's heart is not generating any electric impulses, the machine, the EKG, is not going to be reading uh, any electrical changes, and it's going to show a flat line. So that's why we're going to be trying to resuscitate by giving electrical stimulation to the heart, just trying to reset the pacemaker, all right, making them to start creating electrical impulses another time. All right, so this is it for today's session. Any questions that came to your mind and you want to address? All right, thank you so much. And thank you for making it to the meeting today. Have a good rest of your week and weekend, and make sure to get stuff completed from week 2 agenda. Please also check in on week 2 agenda and in a comment here in the chatting